Well, thanks everyone for joining. I'm really excited today because we have some of my good friends from Permit as well as Piano here. I'm Omkar Saratnam. I'm an engineering director at Google. I'm also a seed investor in both companies and generally a security geek, security engineer, and all around privacy interested kind of guy. So today we have a very interesting webinar for you. We're going to be talking to my friends Or, Gil, and Ariel and seeing a demo from my buddy Philip as to how we may approach handling sensitive data. So to begin with, maybe we'll do a round of introductions. So Or, did you want to introduce yourself?
Sure. My name is Or Weiss. I'm one of the co-founders and the CEO of Permit, an engineer in my background, and a security practitionist, let's call it that way. And I'm currently running and excited about Permit. Permit is basically a full stack permission solution with the premise of you not having to ever build permissions again.
Thank you, Or.
Sure.
Gil, why don't we start with you for introductions on the piano side?
Yeah, so I'm Gil, and I like the pitch that Or gave here. So we are doing the same infrastructure for developers, but for data protection and compliance functionality.
Amazing. And last but not least, Ariel.
Hi there, everybody. So I'm Ariel, CTO, Piano, and as Gil said, we are building a data privacy vault, which eventually should save you a lot of time building privacy security to everything you collect from your customers. And so hopefully,
Yeah, thank you everyone and welcome. Philip, did you want to provide a quick intro as well? You're going to be walking us through the demo in a little while.
Sure, I'm Philip. I'm the developer advocate at Permit, and I'll be the guy that's going to be running you through the demo, showing you how Permit and how Piano work to kind of enforce permissions and secure data. So I hope you're excited about that.
Very excited, very excited. So for our viewers at home or in the office or wherever you're viewing this from, I'll give you a bit of an overview of the agenda. We're going to go through some questions and my friends from Permit as well as Piano will answer them from their perspective. Then for all my engineering geeks out there, Philip will lead us through a demo and then we'll open it up for open questions towards the end. If you're anything like me, you learn more by doing versus hearing. But I think to set context in terms of how my friends at Permit and Piano are approaching this really tough problem, I think maybe setting some groundwork with a couple of opening questions will help with that. So why shouldn't security teams solve data protection problems on their own? And maybe Ariel will start with you and then we'll go around the table.
So thanks for the question. So it's very, very hard to embed security into something that is already done, right? Similar to embedding the chocolate chips into the cookie by the end of the baking, right? You cannot really do it. So security has to be done as part of the development. We are already seeing, the efforts out there to protect security post-development, to protect system post-developments, and the news you are hearing every day about data breaches here and there are basically because systems are not built today with security and privacy by design. That's the short answer.
That makes a lot of sense to me, and I do like chocolate chip cookies as well. How about you, Or? What do you think about this topic?
I think the space that we're living in is changing. Back in the beginning of my career, like back in the days when I was working with Gil in the same office, initially in the army and then later in a startup, the concept of building applications was a lot simpler. We didn't have all of these microservices. We didn't have all of these features that everyone expected that every B2B application would have. And so the attack surface that you had to manage was a lot smaller. So the problem that you had to tackle as a developer or as a security practitioner on the CISO side was a lot smaller as well. But as applications grow and as software is eating the world, and as the layers that we add keep adding more and more layers, it's basically impossible now to just even wrap your head around all the different points of attack surfaces and points where you can expose sensitive data. So if you try and manage all of that as an afterthought, you won't be able to, because you won't even be able to think about it. But if you bake that into the process, into those cookies that Ariel mentioned, you have a much better chance. So while some of us are still set in our ways of, okay, we'll just add security as an afterthought, most times when we go with that and we put things into the oven tends to explode. Again, building on that metaphor. So I really think it's the changing times that are forcing us to change as well.
Thank you. And last but not least, Gil. And Gil, when we first met, I'll admit for our friends at home, one of the first things that struck me about your insight, and not to take away from Or or Ariel, was just your title is CEO, but I know you're an engineer. And I know you put a lot of thought into your product. And one of our first conversations, you said, Omkar, I get the engineering methodology right first, and then we build the product. So when it comes to this question, what's your point of view?
Yeah, so thanks. I think Ariel and Dor said a lot, and I will just add on top of it that I think awareness is the key now. Because like Or said also that, 20 years ago, it was easy, everything was simple. Also back then, security was, a nascent market, and we didn't know what we didn't know. And the same today is about privacy and data protection. And today that more people and security vulnerability researchers show how hacking is done and, all the threats and the fact that we are seeing, the headlines in the newspapers about data breaches and all the bad guys, attacking everybody freely in the internet. We know we need to change and to make a solution. And this solution is something that we found that developers are lacking, infrastructure. If it's Permit or Piano, it doesn't matter, but developers don't have the tools to run fast and to do it. And not to mention that security, yeah, they have engineers, but they are not building the product. If you want to build the product right, you need your own people with the awareness of privacy by design, security by design, and the best practices to build it the right way if you want to mitigate breaches and leaks and whatever like vulnerabilities. So I think this is setting the theme for this discussion today and technically how we are going to approach it.
That's a great perspective. Maybe sticking with Gil for a minute. We talk a lot about sensitive data, and a lot of people have different definitions in their head. As you look at the enterprise, and if you look at your customers and what they're interested in, what kind of data are they saying is sensitive? Like, what kind of things are they concerned about? And what are any special requirements around how that data needs to be handled or protected?
Yeah, so sensitive data is a tricky like definition, and I will avoid define it because I will say it differently. Like, it's up to the company, business, and the industry how you define your own elements that you find them sensitive, that you want to protect more than others, right? So normally it might be the identifiers, like the personal ones, like our names, our emails, addresses, all these things. Maybe the tax ID, social security number, and obviously payment information normally is very sensitive. Sometimes it's even the association to some newsletter like diabetes, or something like that. That's by itself, this connection might be very sensitive and confidential. And sometimes only the business trip or the reason or the name of a meeting is very sensitive. So it's up to the business. And that's why we are avoiding defining something that is clear cut. And how to protect them. So yeah, there's so much to say, and Philip soon is going to show a few examples, but I think, one thing I will say is that when people tell me, when we talk with CISOs, and they're like, yeah, we have encryption at rest, and I'm literally like facepalm, because encryption at rest is like, seriously, nobody's coming into AWS data centers and picking up the hard drives. But if we're gonna start encrypting things and putting them in the right place, and we're gonna talk about that, and encrypting things at the field level, then we start to do good things about data protection, masking them, everything that Philip is going to say. So I don't want to repeat it and spoil it. Yeah, exactly.
So you've certainly hit on some things as to what's wrong with how we're protecting sensitive data today. And I just want to recap something for the audience. I think one of the things that you mentioned really resonated with me, which is the sensitivity of data is highly subjective, right? And it's completely based on your business. So you could be in a business where certain kinds of data are immaterial, and other businesses where they're extremely sensitive, the proverbial crown jewels. And it's really the business and perhaps even regulators of the business who determine what of that data is sensitive. Or I would love to hear from you as to what's wrong with how data is being protected today, and maybe get some of your thoughts as to where we could be improving.
Sure. I first maybe I want to try and actually tackle that definition, but I want to cheat. I want to use basically some economics, and I'd say that sensitive data is the data that your attackers are valuing the most.
Right.
So the more value your attackers can derive by obtaining that data defined as more sensitive. And there's a spectrum, but a lot of data that relates to things that Gil mentioned, like PHIs, PIIs, PCI, a lot of I's are definitely in that category. And the basic fact is that these kinds of elements of data are becoming baselines in almost any application, right? It's almost impossible to run an application today without managing the users and their identities within the application. And collecting them and addressing them and setting some attributes for them. Even just for the security concepts themselves, for the permission and access control, you need to manage those users, let alone enabling them to work with the actual purpose of the application. Especially if you're working in sensitive spaces like healthcare, finance, it's unavoidable to have those kind of elements, those sensitive elements within your application. And then it's no longer a question of do you have sensitive data? It's a question of how you go about managing that sensitive data as it grows with your application, as you grow with the market. And then it connects to what we talked about before, realizing this and realizing that you need to address this in advance, not wait for when it's too late. And when you realize that you have to address this, at least at some point, the next question is, how do you go about doing this? And with a lot of things, the best practice is moving from trying to do the best you can to not rolling on your own. Rolling on your own is an option, and I'm not against it, especially if you know what you're doing, and especially if it's not top of your priorities. But in the end of the day, it's going to become challenging as you move forward and more sensitive elements accumulate in your application. And then you should probably ask yourself, what is the best way, the most cost-effective way for me to manage this as my product, my application is moving throughout time? And it's about recognizing the best practices. It's about recognizing the open source options that you have to build with. And it's about recognizing tools that you can use, and probably better to at least be aware of them early than later.
Omkar, if you don't mind, I would like to add one thing,
Of
some
course.
counterintuitive, because eventually we are here to talk about engineering and two engineers. So I want to give a counterintuitive example for data protection. So for example, when we take, our usernames or PII, identifiers of our users, and normally it happens with the case that some developer is experimenting with some PR and they forget to remove the log line, and suddenly it goes to production. And then Twitter 5 years ago leaked, I don't know, millions of passwords in plain text. And then it's a complete fiasco. So sometimes even sending logs with plain text PII all the way to Datadog or Sentry or whatever you name the vendor, that's against being in control of data protection. So when we say data protection, it's not only about encryption, not at all. For example, if you take a parameter, in a URL, in a get param, it might get logged in so many places all the way to the server or to the other endpoint. So data protection is about being in control and knowing what's going on with the data. And when you reduce the footprint, of this data, then you are in a better situation to control what's going on. And not to mention that compliance, that's another story that don't want to get into, but that's also part of controlling where the data goes and so on.
Yeah, I completely agree. And, you know, as an engineer, our best debugging tool is echo to standard out, and then that gets sprayed all over the place. And yeah, the amount of times that in my past we've had to have discussions about SQL query strings with sensitive data in it, or debug logs with sensitive data in it. This is just going to get bigger and bigger and bigger. Maybe to switch to the inverse, we've talked about a lot of the challenges. Ariel, how should we think about designing these systems to avoid these problems?
So one point we haven't talked about, I think, enough yet up until now, that also changed in the past, like 5 years ago from today, is like the customer expectation. So the customers expect today much more from companies about handling their sensitive data. So today it's no longer, okay, to keep some S3 bucket open to the public and say, hey, we just forgot. The expectation is that you will use the tools and the processes to make sure it's not happening. So that's basically what, again, is privacy by design about, to make everything such that simple mistakes cannot really, compromise everything, like, again, forgetting that bucket. So going back to the, customer expectation and protecting customer data and talking about, the priorities of what data is sensitive or not. So at least from that perspective, you want to protect your customer information, right? That's becoming more and more, important for companies around the globe for, obvious reasons. And then the question is how you can do it, right? There's so many customers data everywhere, because usually you collect the data and then you copy it to one system to another system. You build many microservices, and each microservice needs its own data. So it's being copied again and again, and it's in so many places. And when you need to apply security, when you need to apply the compliance requirements, the privacy compliance requirements, it's very hard to do it when it's spread all around, right? So I think the most important principle that should be, taken into account is how to limit the footprint, as we said, how to centralize what matters. And what matters usually is the critical identifiers, like PII. And the reason for that is not because the PII is more sensitive, let's say, from the data next to it. In many cases, the data next to it is much more sensitive, right? The point is that usually, or in many cases, if you separate the identifiers, you render the rest of the data not interesting by itself. That's what's called pseudonymization or de-identification. And using that principle is something that can help a lot of companies to focus on what matters, to prioritize the effort. And what I'm saying eventually is think about what matters to you, and make sure to put it in a place that provides you everything you need, security and compliance was similar to as you're not keeping your jewelries all around the world, like your house, you eventually centralize them in one place. So that's the same concept. So that I think is
maybe I will give an example so the audience will understand it in a clearer way. So imagine a data warehouse for analytics. Normally we talked with hundreds of companies by today. Everybody sends everything to the data warehouse, inclusive with all the identifiers, sometimes with some payment transactions, hopefully not the credit card itself, but eventually most of the companies, in 99% of the times, they don't need to know that this is the data of John Doe. It doesn't matter for their aggregated statistics. So what Ariel is suggesting is that if you omit or tokenize some of these identifiers and they are not appearing there, and then you give this information to your data scientist without the identifier, so it's all de-identified, now it's becoming a business enabler. Now, as a CISO also, you don't need to be afraid if this information is stolen, because it's not going to identify the data subject. So that's like the way we look at it.
Yeah, the other thing that I'll add, just from my own personal observation, is a lot of the concern about PII is the permanence of it. It's awfully hard to change your name. It's impossible, at least here in the States, to change your social security number. I mean, I presume there's instances, but it's extremely difficult. However, generating a new bearer token, generating a new hash, just change the salt, and maybe that's okay. All right. Philip, I think we are just in time for your demo. Are you ready to demo for us?
I am ready.
Excellent. Over to you, my friend.
Awesome. Okay. So let me just screen share. Okay. So within this demo, we're going to kind of look into how permit works, how the authorization side works of controlling users and controlling the access that they may have to the application. And then we're also going to look at how Piiano kind of controls this encryption of the secure data that might leak into the world and might meet some eyes that we wouldn't want them to, or some people that we wouldn't want to see that data. So what you can see is a very simple application. It has two profiles where you can learn more about a specific person. And you can see a very simple control panel. Now, this control panel here, where I can change between users, is a very simple representation of what would be an authentication service. So you'd be logging in, and suddenly you'd be getting a role. And we can see three very simple examples. We can see a stranger. We can see Ariel here, who has the role of a friend. And we can see Philip here, so myself, who I've given the administrator role. Now, I want to kind of go through and show you how these different roles work together. And as I change, I'll show you how this kind of token gets stored in the cookie for each person. And then I'll go into how permit kind of restricts the authentication to the application and how Piiano kind of encrypts that data. And throughout this demo, we've introduced some security flaws that maybe you guys will spot before, or I'll ask you guys to maybe find a mistake to keep it a little bit interactive throughout. So as you can see, for example, if I switch to Ariel, who is a friend, if I'm on my inspect panel and I'm on my application, you'll be able to see down here in the bottom right that we've got this bearer token that signifies to us that this user is currently using the application. And the same thing, if I switch to Philip, you can see it being switched to Philip. And if I go back to a stranger, well, then, of course, we don't know who this is. And that's kind of the identity that we give them. Now, as a stranger, if I want to learn more about Ariel, or if I want to learn more about myself, well, unfortunately, I cannot do that. I'm unauthorized to do that. Now, with Ariel, who is a friend, he's given more permissions to do certain things within this application. And for example, he can learn more about himself. And he also has access to view and copy his social security number. And because he is the owner and he has confirmed his identity, we can see that he can actually read his own social security number. Now, if I go into administrator and I view things as myself, well, why can't I do things? And this is actually a thing I did for a reason to show you how we can integrate these permissions into permit very, very simply and very quickly to give myself not only the role, but to give myself the right permissions to do things. So if I actually go into the policy editor within permit, and I'll move over to the policy tab, we'll see that we have two roles configured so far. We have the friend role, and we've got the stranger role. Now, we've got a specific resource that we're going to be checking how we perform permissions on and the actions that we can perform on this resource. And we've got 4 actions. We can view a personal information, and we can view public information. And also we can view public SSN numbers or view private SSN numbers. Now, the stranger, of course, has no permissions to do anything. The friend role can only view his own private social security and view the personal information. But we're missing the administrator role. So we need to create that. So it's very simple. We just click on create a new role. And then we just call it whatever we want. In this case, I want to be the administrator. Now, as you can see, the same card, the same resource with all the actions populates for that new role that we've just added. And it's the case of very, very simply just checking all the boxes, saving those permissions. And at this point, that policy generates in real time. Now, within the permit setup, because it's an application level authorization service, we create enforcement points within our application. And those enforcement points check essentially and hit something that we call a PDP. It's the policy decision point. Essentially, it's a Docker image that we provide and that you can deploy as a sidecar in your own infrastructure. And essentially, that updates those policies in real time. So the permit UI abstracts away from those complex legal policies that you create and allows you to kind of really do it in a very simple way. So now if we go back into the application, you might think it will work, but it still doesn't. And there's a very good reason for that. And the reason is that actually we still need to give this role to this specific user that we want to give those permissions to. And we can just go over to the users panel, and you'll be able to see that we've got the unknown user who's been given the permission of a stranger. We've got Ariel, who is the friend in this case. And we've got myself with no current permission. And it's very simple to give a permission. You just click on the role, assign it an administrator, and save. And now that policy has been updated again in real time. So now actually, without even refreshing the page, I'll be able to learn more about both of us because I've got the permission to do that. And also in the same way, I can view my social security number because I'm the owner and I'm the current person that's actually logged in, which you can see from this bearer token. But then also I can view Ariel's as social security number. But as you can see, I can't actually view all of it. I can only view a certain part because that social security number has been masked. Now, the problem is here that this is actually a vulnerability within the system. The problem is that even though this social security number is masked in the front end for me, if I actually go into my network panel, and I'll clear all these requests and I'll ask to see that social security number here again, if I click here, what you'll be able to see that actually within the network panel, that whole social security number is exposed to me. So unfortunately, that is a security risk, and there is some way that maybe we might have to deal with that. And I want to show you guys a quick example in the code where we can see that we're doing this whole social security masking on the front end. So even though the server is sending back the data from the database, unfortunately, we're just replacing part of the string with the X's and showing that to the user. But that's a security breach, and we shouldn't do that. Now, of course, every time I view these permissions as well, there's also another check that happens, and that check is the permit check. And I want to show you that function. So the permit check is a function that we embed into our code. And essentially, it takes the unique user ID that's currently logged in. So usually, this is the ID that you would get from the JSON web token, the unique ID of that user. You have to pass in an action that you're performing on the current resource. And a very simple example of that is in the get user details. We actually, the function that we define here is called isUserAllowed, which performs that permission check. And here, we're actually passing in the user from that request, the view personal information action on the resource, which we defined as card. So that's how those permissions within permit get defined. But as you could see, even though those permissions are enforced, that security risk also exists. Now, let's actually close these profiles and go back to Ariel, who is our friend. And in this case, we're going to talk about a specific case where, for example, Ariel can learn more about himself and view his social security number, but he can't see anything on my profile. So essentially, he has no access. And that access is restricted by permit. However, this is where another security breach comes in, which is a little bit more serious, because even though this social security number is coming from the backend, and technically Ariel shouldn't have access to my profile, if we actually click and go over to the URL, we can very sneakily edit the URL. And instead of Ariel, we can actually pass in my name or my email in this case, and get exposed to my social security number. So even though Ariel was restricted, still he could play around with the network tab and change the URL parameter, and suddenly that social security number is now exposed to the whole world. And that's another security breach that we have here. So how do we fix that? And this is kind of where Piiano comes in to solve that issue for us. So essentially, if I now have this toggle, which is protecting the data with Vault, suddenly we're going to be using a different database. And I kind of want to illustrate that and show you in the terminal how we populate those databases and give you a visual example of what actually happens. So I've got this script that actually launches Piiano, and it populates, it pulls those images and populates that database. And for visual purposes, we have a really nice kind of UI here to show you that currently we're dealing with a database that stores all our information. It stores the email in the database, it stores the exposed social security number, and other information about the current user. Now, what Vault does is essentially you can specify to pull out specific parts of the information that will no longer exist in that database and create another database within the Vault, which will have all of that relevant data encrypted. So in this case, what's relevant to us is maybe the email and the social security number. So essentially what Vault does, as you can see, it pulls out that information that we have currently, and then it actually converts it and encrypts that information into a random string of numbers and letters and signs that is essentially unreadable, and you can't unencrypt that. So that's the example. Now, by toggling this switch to protect the data with Vault, what is actually happening is that we're, instead of using the usual database to fetch the social security number, what we're doing is we're using the Vault, where all those encrypted social security numbers are stored. So now, if we actually go back to the two examples, the first one, the first vulnerability within the system, where I myself as the administrator can view my social security number, and I can also view the masked version of Ariel's social security number. If we look in the network tab, that social security number now comes in masked. So even though there is a mistake in the front end and we're just masking it in the front end, it still comes in masked from the back end. But what happens to the other part of the vulnerability, where, of course, Ariel, he can access my social security number, which I maybe wouldn't want. Well, in that case, actually, we can do the same thing. We can try and see and access my details. Well, we cannot, but we can refer back to the details here previously, where we get Ariel's social security number. But now if I actually change it as a user that's not logged in, so I'm not active in the system, what you'll see is even through this flaw, we don't have access to mine. It's still coming from the Vault, and it's still encrypted. So even if there wasn't enough security and on the server side where that social security number is coming from, well, unfortunately, it's still safe and protected. Now, I actually want to jump into the code and do a little task where we have two specific, not this one, but here. And actually, I might need to zoom out for this a little bit. So just bear with me so everyone can see it. There we go. And here is a little bit of a challenge of here, like that, of being able to spot the flaw within the system. What is actually going on? And more specifically, we're talking about the first couple of lines here and here. And I don't know, some of you maybe have already noticed, some of you maybe have not. But the actual difference here is that for the first check, the one where we check for the user details, our request user ID is actually fetched, and the current user that's logged in is being taken and compared with the user that I click on the card. So there is a very strict comparison here. Now, the problem with the normal other SSN is the fact that it's very easy for a developer to make a mistake. It's very easy for a developer to, for example, specify the request ID, and maybe I can zoom in on this so it's a little bit bigger. Specify here the, just bear with me 1 second, let me change the screen. Okay, the request ID here in the same way, and the unique user ID to be fetched from the request. So in this case, this provides a vulnerability where this statement here is always true. So as long as it passes that authorization layer, this statement will always pass. And what will happen is actually this very simple vulnerability exposes all the social security numbers in this case. So it's the case that you can't always trust a developer not to make a silly mistake like this. It can be very easily missed, and unfortunately, it can cause a lot of problems in the future. Now, with that, I know Ariel wanted to say a little bit about the actual system, and I'm just going to bring up the image here so he can kind of go in and describe it a little better. So Ariel, do you want to?
Yeah, thanks, Philip. So just to give some, a bit more detail. So what we all saw here together is that it's as easy as just, one mistake and copy paste, that you really get your system very vulnerable to something very serious that leaks sensitive data like social security number. And the point what's happening is that, as you can see on the top, on the left side, right, the database cannot really know, who is the end user accessing the data. So he basically trusts the compute, the web service in this case, to make the access decisions, right? And that code that makes the access decisions is eventually you guys, you, the developers, the engineers. You need to make sure you not forget anything. And there is so many code and so many services, and there will always be some issue there. So with Vault, what you can do is, as you can see on the bottom, right, is that actually you pass on the JWT token. That's what we are doing in this demo. You're passing on the JWT token all the way from the end user to Vault. And then within Vault, okay, as you can see, on the right side, on the the code snippet in the right side, in the middle right side, is that code snippet shows you what really runs in Vault to make sure that really within Vault we make sure that the email from the JWT token matches the email of the data being accessed. So even if the developer forgot, right, to make that access check in the web server itself, it's not going to leak anything. And the point is that if you look from data perspective, not from all the APIs perspective, but from data perspective, there is never a reason for the web server to fetch SSN if it's not for the user itself, right? So that principle can actually be enforced within Vault. And then again, even if there is a mistake, and there will be mistakes eventually, you are covered by Vault. So that's in a nutshell what we are seeing. And on the top right, you can see that's really the Vault, that's a snapshot from the policy. The Vault is not allowing fetching social security number, but only the IDOR protected version of it. IDOR is the name of the bug, or writing data to social security number, as you can see there. So reading is not allowed to the social security number directly, but only to a snippet or a version of it that is protected by the code snippets below it with the JavaScript that matches the email to the owner of the data.
I think I'd like to add here something about the demo. As a general rule and best practice, you always have to check permissions on the back end, never on the front end. It's okay and cool for demo purposes, but don't do it at home, kids. And I think what this demo really shows nicely is how you can come against the weakest link principle by having security embedded across your chain, across your stack. So you have permissions and things like permit and OPA kind of gating access to the application itself, but still you're protecting the data at the edge, or more correctly, at the source, where you're working from the database through the Vault. So no matter what kind of friction or attacks or threats your application is facing, you've got all the areas that you need covered, and you're better prepared for attacks.
Yeah, and also from the centralization principle we talked about earlier about the sprawl of data versus centralization. So that principle also shows you, right, in a way like something similar within the application. So if you have like many decision points, eventually it's hard to make a mistake. If you centralize the decision point in as much as you can, then it's harder to make a mistake because it's more in focus that place.
And that is true for both the solutions we presented here, both permission checking and data security. We have a single plane that controls those elements, and we don't need to rebuild it or replan it or restructure it for the different microservices or even different applications that we have.
Yeah, I guess it's about consolidating the management of either accesses or...
Ironically, it's both decoupling. So you're decoupling the responsibility of managing that security element from the application itself, but also having a centralized control plane where you can apply it to your various applications and microservices.
I think also it shows more about in this demo about you guys that it's another team giving permissions. It's not the developers. So that's also like very important to see how eventually a big organization building a whole software product, there are many moving parts, many teams. So this is how they work together. It's the same in the Vault, but we haven't deep dive into this now.
I agree with all of this. The one thing I took a grave exception to is the inference that engineers might make mistakes. I mean, I've never made one, so I don't know. Is that a real thing?
There's always a first.
I know, there's always lines of code.
You're the manager, right?
The other thing that I wanted to jump on here, in all seriousness, I think the idea behind centralization is so important. Humans are naturally inconsistent. And because of that, we have a lot of these kind of permission and access issues across the board, especially, as you guys highlighted, as we move more and more to microservices and individual APIs for access that this person or that person in different offices, different desks, different parts of the world may be developing. And being able to bring that consistent control plane also allows us, if you follow the security principle of presumed compromise, it also allows us to quickly make changes when we do discover issues in a way that's durable, and you don't have to go through and figure out, oh, how did Sally versus Bob implement this particular API for accessing this particular data within this database. Completely agree with you.
Omkar, I'm curious, if you don't mind me asking you a question.
How are the turntables?
Yeah. And you know, coming from or working in big companies like Google or JP Morgan Chase before, and you were responsible for data protection there, most people find centralization like counterintuitive or something that doesn't feel right, you know, because how come in complex, you know, architectures today going with divide and conquer like microservices, now we are sitting in this room and we think we know how to do security and we did a lot in our life. And we talk about centralizing. It's like contradicting everything. So how would you, you know, approach it and give the rationale behind it?
Yeah, I think it's. Thank you for turning the tables. I think it's a little different at Google, in a lot of ways. Only, I mean, the first thing I'll start off with is Google's a much younger company than any other company I've worked at. It's only been here like 24 years, right? And also, it was kind of designed from ground up on certain technology first principles that allow this to be done much more easily. Like, rare is the instance of us not having access to source code for something that's running in production. Very rare. Whereas, if I think about my time at JP Morgan Chase, it was almost exclusively commercial off-the-shelf products, which of course limits you. One of the advantages that we had in the data protection program that I was running at JP Morgan Chase was, one, there was a top-down desire due to a bunch of regulatory changes that came down the pipe after the 2008 financial crisis for the bank to get much better around data management, data lineage, and transformations of data, because a lot of the financial, I'd say the miscalculation of risk during the 2008 financial crisis was attributed to not understanding the lineage and transformation of data that went into the risk models. So that top-down pressure was very helpful to us because we were building, I'll say, a poor man's version of what the Piano Vault builds, right? We were trying to do this for the enterprise. And as we went to each of the CIOs and said, hey, this is what we're doing, their eyes suddenly lit up because now we had made this problem much easier for them because the data was in one place. The other thing that we did, and this gets to what my buddy Or's working on, is we provided SDKs to make this easy for the developer. I identify as both an engineer and a security guy. And the engineering part of my brain, if one of these security guys comes to me and makes my life harder, I'm going to be upset. Like, I want to work on other things other than, you know, this compliance tick box. But if you provide me an SDK and you say, hey, this is the vetted method for retrieving data, this is the vetted method for protecting and reading sensitive information, and take that out of my hands and absolve me of the concern, then I'm a happy camper. And that's what we did for our developers, right? We made it easy so that rather than them feeling like something was compelling them and that it's more work and it's another headache, this was the easy button. So that's how we approached it. Does that answer your question?
Thanks.
Awesome. Now, when we went through the demo, and I think during a little bit of the discussion, there was a question around OPAL and what role this can play in kind of orchestrating this ACL of ACLs and maintaining consistency. Or did you want to give us a description of how you see that playing into addressing some of the issues that we were talking about today?
Yeah, for sure. So maybe as a bit of background. So OPAL is an open source component that is baked into Permanence, an open source component that we've built. It stands for Open Policy Administration Layer. It's essentially a way to load data dynamically and policies dynamically in real time into your policy decision points, and specifically into OPA, Open Policy Agent. And when we started building permits, we ran into a lot of the difficulties that we discussed here today. With permissions, with authorization, there's a lot of sensitive data that you potentially, our customers, we want to gate access to. And that sensitive data might need to be involved in the decision-making process, in what the decision agent needs to make those decisions. So you potentially need to load them into the agent. But as a SaaS vendor, starting to manage all the different sensitive data points that our customers might have is a big pain point. We can start using Vault, and we can start maybe creating more layers to protect ourselves. But in some cases, it's easier to mitigate working with sensitive data by not working with the sensitive data. And that's something that also I think as a best practice you should consider. What sensitive data do you have to have in which parts of the system? Essentially having a need to know basis approach or a zero trust approach. So but for building Permit and for building OPAL, that component to load the data, we adopted that need to know basis concept. So instead of the control plane, instead of the OPAL server constantly getting all the data points and sending them to all the agents that need them, the OPAL server only sends instructions to where to get the data, to the clients, to the OPAL agents at the edge. So that way, only the edge point that actually needs the data, which can actually reside on our customer side, only that area has direct access to the sensitive data at all. So we basically separate, we decouple, kind of mentioned decoupling before, we decouple the control plane and the data plane. So the control plane can be, for us as a SaaS vendor, can be basically sensitive data free. And each of the edges points that need sensitive data will only, through topics, will only get the data that the sensitive data that they need. You still need to manage the data at the edge, and using something like Piano there, I think is a terrific idea. You can basically tell the OPAL client, fetch the data from the Vault instead of from the database. In that way, solving that friction point. But at the first thing we did is minimize the attack surface, minimize the area that we have to protect. And I think that philosophy of decoupling, but having a centralized control plane, but a decoupled area where you manage both the security itself and the sensitive data itself. I really think that's a good philosophy to have, a good best practice to use.
That's a great point. In fact, thinking back to my time at JPMC, we had this quick motto, which was reduce. So reduce sensitive data wherever you can, to your point. Redact if you don't need it. Tokenize if you need something there. And if you actually need the data, then encrypt. And I'm really happy to hear that you're following the same thinking, and at least, as my wife often, well, I say, great minds think alike. My wife says fools seldom differ. So take that as you will. Maybe moving over to Ariel. Ariel, we've talked a lot about stuff. And to think about one of the standard patterns that we've used in the past for protecting data, you encrypt data with TLS, you stuff it in a database, encrypt it at rest. Maybe you're doing table level encryption. Why isn't that enough? Why can't we just do that and be done with it?
Or PG crypto. Like
yeah, so that's a great question. As Gil said earlier, right? Encrypting like that at rest encryption today is not really solving any practical, threat, right? It's basically solving the problem of somebody stealing the hard drive. And anyhow, Amazon has like a army of people saving on the data centers themselves. And then encrypting in field is something very valuable. As you said, it's valuable once you really need the data, right? If you don't need it, don't take it at all from the first place, right? As also Or mentioned. But the point is that encrypting data in field level, right, is very hard, is something very hard to do. And by the way, the reason to encrypt in field level is for example, if some admin accessing the database, you can see the data. But also we are seeing like many, bugs happening on, cloud providers where one customer can see actually somebody else's, information on the database. So eventually you do need to encrypt sensitive data, what's called like field level or table level. And then doing it yourself in the application level is very, very hard. I mean, not the encryption itself. The encryption itself is just like one function call, right? Even like the database is sometimes supported. But the point is, how do you manage the keys? How do you manage the access to different types of keys that protect different types of data? And that becomes a headache, especially if you also need, you want to support many types of data, and then you need to rotate the keys because the regulators they mandates to do so in many cases. So doing all of that, again, with a way to manage all of it as you scale, going back to what we talked earlier, is very, very hard. And for example, Piano Vault, what it does for you, just doing all of it behind the scenes. As a developer, you just access the API, and you know that behind the scenes, the data is being encrypted, rotated, the different keys are being used for different data types for you. You only need to access the data, and then somebody, either you or the security or privacy team will configure the policy. It controls who can access, what types of data that is being encrypted by Vault itself by different types of keys. So that's, again, it may sound simple in the beginning, but if you think about, all of it, it becomes much, much, much harder than that.
I guess the key is scaling a system with encryption. So yeah, people use libraries all the time and park the information in one database. But when you want to scale, it's becoming much harder. And again, it's about management and consolidation. And that's the key with the Vault and centralization approach as well.
Maybe one more point is that, okay, you encrypted the data, but now you need to use it, right? So just decrypting it is one thing you may want to do, but then what if you need to perform queries over the data, right? Then it becomes even much, much, much harder, right? So solving all these issues yourself usually is not something you want to do. Again, as you scale, maybe for very, very specific use cases, and it's better, to use some off-the-shelf product that does it for you.
I think it's really about the journey. As you build your product, as you build your company, as you build your offering, more demands are going to come in. Like initially, when you're just giving it to the first couple of customers, even if it's in-house or external, there are not a lot of expectations. But as it grows, security and compliance requirements are going to come in either from certifications or from just having to face reality. More interfaces are going to be requested by different people. Analytics, like analysts, we want to work with the data you're producing. Sales and professional services, we want to interact with the application to help the customers. And as more and more things pile up, it will become harder to make sure that all of these points that we mentioned are handled well. So you can handle them well in the beginning, but it can become more difficult. And then the question is how you transition. And I think nobody should start by adopting all the tools in the world. You shouldn't, from day one, have the best permissions and the best data encryption, but you should have the ability to adopt them when you need them. So have that in mind, have the awareness of where these friction points are going to come in. And when you do arrive at them, know what are your options in the source of open source, in the source of services, in the form of changes that you need to do to the application that you're building to actually achieve that. And that way you have a smooth journey as opposed to a painful one. And I guess that's what most of us want when we're building things.
Absolutely.
I like to say on top of this, that one of the tips we give to friends, they ask us, okay, we don't want to do privacy or data protection as a startup. We just need first, to get to the next level. We are struggling like everybody else. And then I tell them, look, at least what you can do, it's going to help you going forward into the future of, let's suppose that you are becoming a successful company. And one day people will ask you about SOC 2, and one day you will start to care about GDPR and CCPA and others. So at least the best thing you can do is centralizing all the PIIs in one place. And why PIIs? Just because regulations. But if you centralize them in one place, later on, it's going to be easier to migrate them, to fix them, to apply default in them, and being in control, like we said earlier. So that's a key takeaway I would tell to the audience here.
For sure.
I think that's a great point. I think it seems more bureaucratic at the beginning, but being able to establish where all your sensitive data is at the very beginning, before you become super massive, and start to get those practices of ensuring that the catalog's up to date, that it's all put in a vault, all of that makes sense. I also wanted to touch on points that I think all three of you brought up, which is the notion of agility within both the control plane as well as the data plane. And what I mean by that is policies are going to change. You want a central method of changing the policies. You want to be able to do so in a metered fashion. Anybody that has managed a distributed system at scale will tell you fast changes will break things. Slow, moderate changes that you can observe over time through a centralized control plane will save you so much hassle in the long term. And then, nerding out on the crypto side of things with my friends at Piiano for a second, the notion of things like crypto agility. We're on the cusp of ratifying post-quantum encryption ciphers. Everybody, at best, is using some form of AES today. Maybe some are still using some legacy symmetric encryption. But I would love to get your thoughts as to how Piiano, as this massive vault, is thinking about like storing this sensitive data, not just for today and tomorrow, but for the next decade, and how you're approaching things like crypto agility within the vault.
I, I will say something high level, and then if Ariel wants to talk about, the encryption and stuff. But people ask us sometimes, or investors, like, hey, are you guys, what do you think about homomorphic encryption? And I'm like, seriously? And now among engineers, I can say it's bullshit, okay? Like, there are maybe some use cases that that it can be useful, but in terms of performance and what you get out of it, it's not really there. It's not meeting your requirements, okay? And then I'm saying, let's suppose that in 10 years, it's going to be like amazing and super performant inside production environments. Sure, we're going to use it, employ it in as part of our Vault infrastructure. So you don't have to. And that's the point of building infrastructure for everybody else. As you know, even compliance gets more already with CCCPA and then CRPA, and then even California by itself is evolving its own regulations. So we are going to take care of you. And I think it's the same message also with Permit. Once you have this established like foundation of working with, as you said, the policies and management, now it's easy to change it. Yeah, you might break things, and maybe in the future they will introduce also us more testing and stuff like that. But now you can move fast, and you don't need to change the code. That's much more important than patching the code every time you want to add a role, like Philip showed us earlier. Back to you with encryption stuff.
No, I think it's the same about everything we talk, like centralization. Once you centralize, what matters in one place. So if tomorrow, all the crypto today is broken, right? We will fix it for you. Okay, we are really providing you the infrastructure. As long as it's centralized in that place that is built for that, and that's our business to protect it, we will make sure it's always up to date with the recent, cryptographic algorithms that make sure it's protected. So we not need to do it. And then on top of that, right, talking about data that's is all over, and sometimes you do need it to be in many places. That's also a reason for favoring like tokenization over encrypting it and passing it on, because if it's tokenized, then it can never actually be broken, right? Tokens are basically non-sensitive at all by themselves. They're just like pointers to a table or to a lookup table into something within Vault. So again, it still keeps the what matter centralized, but let you still allow data to travel once keeping it safe. That's
Great points. Great points.
Actually, in the future, we believe, PIIs shouldn't be sent to the servers. And in most cases, maybe it's possible for e-commerce example, not with governance and stuff like that. But going into the future, it's not about more encryption. It's about really doing some order with the way, people share their information. So imagine you're going to have a chip on your phone or whatever it's going to be in 15 years. And then there's going to be a PII wallet with some verification of, hey, I'm a human and the government verified me and I'm using your service, without you knowing who I am.
Yeah, an ephemeral disposable token.
Right. So you still need Amazon to send you the shoes, right? But there might be physical proxy stores to mix your addresses and whatever.
This masterclass is not sponsored by Amazon.
Yeah, that would be awkward. So, gentlemen, we only have a couple of minutes left. I'd like to go to each of you for maybe just a couple of sentence call to action for the audience. Or why don't we start with you, then we'll go to Ariel and finally to Gil. So what's your call to action for the audience?
I think the most important thing someone can take out of this is kind of a glimpse into the future, a glimpse into the problems they're going to face, and the best practices that they can harness today to go about facing these challenges. And I said this can be a daunting task. The challenges are constantly increasing, and everything is shifting left, and more people need to be involved with the applications we're building. So it's definitely not an easy task, but start thinking about this today, start adopting the best practices, and even more importantly, start having these conversations internally within your organization and also with us. And that's maybe the best call to action I want to add here. I invite all of you to reach out to us at Permit. We have a very welcoming Slack community. Just go to Permit.io. There's a community link on the top right navigation. join us in Slack, ask us questions about what you're building, about security in general, about permissions. We always love to chat with our fellow engineers and security practitioners. And you're also welcome to reach out directly to me. I'm Orweis, Orweis, basically everywhere on GitHub, on LinkedIn, on Twitter. Reach out to me. I think you'd be surprised how happy I am to chat with you.
Thank you. Ariel, your call to action for the audience?
Yeah, so first, you're also welcome to approach us at Piiano. We don't have a Slack channel, but the website is also a place you can always approach us. I think on top of what all said and what we said already in the last hour, I think to the point of building security and privacy by design, try to think when you design the system, how you build it such that even if the engineers will make mistakes eventually, and they will make mistakes, we saw a few examples in the demo, but
I don't know about
it's
that.
always happening.
Yeah.
So try to build it in a way that even if these mistakes are happening,
Yeah.
okay, the system, the design protects you. I think a very important principle. And centralization, again, is a way to achieve it because you reduce the footprint, but it goes everywhere. So that's my thinking.
Maybe to clarify that, it's not you as an engineer making mistake. It's that other engineer that sits next to you
The one
that is going to make a
Got it.
mistake.
The one that we join
The other
tomorrow.
one.
The one that doesn't need to be
The other
here.
one. And I know we're a little over time, but finally, my friend, Gil.
Gil?
Yeah, I think you covered everything. So key away is just the fact that you are here and listening to this. It means you have awareness. I'm sure people learned something, and yeah, just let's make the world better. That's really why we started this company. As you said in the beginning about me, I love to find 0 days and security vulnerabilities. I still do it in my free time from time to time. But the point is, it's not going to change the world, and the reason we are here as entrepreneurs and trying to build all these great products is to help all the companies out there to work with necessary data. So the key takeaway is let's do security with love.
Aw.
That sounds
And before we end quickly, I'd just like to jump in and say that if you're eager enough to try out the demo, you'll be able to find it as a GitHub link in the description. You'll be able to see the whole guide there to launch the project, to play around with it, to really dive in and experience how Permit and Piiano work, not just alone, but also together. And also, if you would want to follow a slightly more extensive guide that goes into more detail, there will be one on docs.permit.io that we'll publish very soon.
Thank you, Philip. Thank you, Gil, Ariel, and Or. And thank you to the audience for joining today. See everyone soon, and stay secure, stay safe.
Thank you, Omkar.
Thank you, Omkar. Yeah.
Pleasure.
Thanks, everyone.
Bye.
Bye.
Bye.